This is Ahed with Logos Learning, and in this video I will speak about chemical reactions. I'll briefly introduce what they are, and I will briefly introduce the different types of chemical reactions. Now, what is a chemical reaction? In a chemical reaction, one or more substances called the reactants are converted to one or more substances called the products. So as you notice here we have a chemical equation. On one side we write down the reactants, on the other side we write down the products. Now, chemical reactions, as opposed to nuclear reactions, they involve only the valence electrons of atoms. So here, this is a valence electron because it is on the outermost shell, or the valence shell. Valence shell. Now, chemical equations, like the one we've seen, are used to communicate what occurs in chemical reactions. These reactions in the equations must be balanced because of the law of conservation of mass. The law of conservation of mass states that during the course of a chemical reaction, matter is not created or destroyed. This is as opposed to during the course of a nuclear reaction, in which matter can be converted to energy and thereby is no longer matter. Now here, in the synthesis of water reaction, we have hydrogen gas and oxygen gas as the reactants, and we have water as the product. Is this equation balanced? Let's see. On this side of the equation we have two hydrogens and we have two oxygens. On this side of the equation we have two hydrogens and one oxygen. So here we have only one oxygen and we need two. So let's start by putting a 2 here. Now we have a problem. We have two oxygens and four hydrogens. So we have four hydrogens and two oxygens. And here we have two oxygens, great, but we have two hydrogens. So if we put a 4 here, or sorry, a 2 here, now we have four hydrogens. Do we have the same number? Four hydrogens, two oxygens on one side, four hydrogens, two oxygen on the other side, and bingo, we did it. Let's balance two more chemical equations. Hydrogen gas plus chlorine gas is converted to HCl, hydrogen chloride, or hydrochloric acid. So we have two hydrogens here and two chlorines, and here we have one hydrogen and one chlorine. So what should we do? Yes, you're thinking correctly. Put a 2 here. If you put a 2 here, this 2 applies to the hydrogen and to the chlorine. So now we have two hydrogens and two chlorines, and bingo, we balanced it. Let's do one more example. So we have HCl, which is hydrogen chloride or hydrochloric acid, plus sodium sulfite, because of the 3, yields sodium chloride, water, and sulfur dioxide. Let's balance. I like to start with the larger elements, like sulfur. So here we have one sulfur, and here we have one, so that's good. Let's see sodiums. Here we have two sodiums, and here we have one, so we must put a 2 here, just for now. So we have two sodiums here, and this gives us two chlorines, so I know I need to put a 2 here to make sure that there's two chlorines. So now let's count the hydrogens and the oxygens. So we have two hydrogens on this side, and we have two hydrogens on this side, great. Now oxygens, we have three oxygens here, and here, please God, 1, 2, 3, yes. So this is how we balance this equation. I don't like to write down all of these things, because once you get used to this, you don't need to do that. Just start with the larger elements and move to the smaller ones. Now, types of chemical reactions. We have 5 general types of chemical reactions. The first one is called synthesis, or making. We are making, building. You're synthesizing something, you are making or building something. Now, the simplest way to put it is you have compound or element A plus compound or element B gives you something that has both of them, that has a combination of these two. We'll look at examples in the next video. Decomposition is the opposite, is breaking. So this is making, this is breaking. The opposite of synthesis. So we're going to rewrite this the opposite way. AB, compound AB is broken down to form two constituents, A plus B. Now I know I'm going fast, but in my next video I will discuss synthesis and decomposition in detail. Single displacement. So let's say we have compound AB, and this compound reacts with the element C. Now C is going to replace A in this reaction, so we're going to write the product as CB plus A. So C replaced A. Now, double displacement, so you have two elements displacing two other elements. So let's say we have AB plus CD. Now here, the way you think about it is that we're going to exchange the first one of each one. So we're going to have, so B stays, we're going to put C there to exchange it, plus B goes, or A goes on the other side, AD. So this is double displacement, and I will discuss this in detail in its own particular video that's coming up today or tomorrow. Combustion means burning. Now, generally speaking, in chemistry, when we talk about combustion, we talk about the combustion of carbon-containing compounds. For instance, you burn propane, C3H, so 3 times 2, 6, H8. Now, C3H is H8 is propane. Let's write this properly. Propane. And when you burn something, you need oxygen. You learned this in grade, I think, 1 or 2. To burn something, you need oxygen and heat. So we're going to put heat and oxygen. Now, triangle, hopefully nicer than the one I drew, means heat. So we're given oxygen and heat, and combustion, if there's enough oxygen, always yields CO2 and H2O. So combustion of a carbon-containing compound, something that has a C, if there's enough oxygen, always yields CO2 and H2O. Let's balance this just for the sake of this video. We have 3 carbons here and 1 here, so let's put a 3 there. Now, this causes us to have 6 oxygens and 1 here, that's 7. Let's put a 2 just to make it nice. So here we have 4 oxygens. Oh, we're going to need a 4. If we put a 4 here, and this is getting messy now. So let me restart with you guys. Now, there's 3 carbons, so I must put a 3 here. Now let's count the oxygens. We have 6, 7. And here we have 2. So let's see what we can do. Let's count the hydrogens. We have 8 here and we have 2 here. So if we put a 4 here, we have 8 here and 8 here, which is great. Now let's work with the oxygens. We have 4 oxygens here, and here we have 6. So 4 and 6, 10 oxygens on the product side. So we need to have 10 oxygens here. If we put a 5 here, that'll give us 10 oxygens on the reactant side as well. So stay tuned for my next video, in which I will discuss in detail the first 2 types of reactions, synthesis and decomposition.